Greetings everyone, and welcome to this video in my lecture series on binary, octal, and hexadecimal numbers. In this video, we will convert non-integer decimals to other bases, looking at the particular instance of numbers less than 1. So for our first example, we're going to take the number, a decimal number, and convert to binary. So you're going to take 0.8125. And I haven't written a subscript because this is a decimal number, though I could do subscript base 10 if I wished, to binary. And we're going to use the method of repeated multiplication. So I'm going to take my number here, 0.8125. Now we're going to notice that this number is less than 1. So my answer in binary should also be 0. something something something. And so we're going to take this number and we're going to multiply it by the base. So we're changing this to binary, so we're going to multiply it by the base. That is going to give us a decimal number, 1.625. We're going to break that into two parts. We're going to write first separately the integer part, the part before or to the left of the decimal point. And then we're going to write the non-integer part over here. We're still in the base 10 system right now, so I suppose you could call that the decimal part. It's 1.625 on your calculator, and we're going to write that as 1 plus 0.625. So the integer part goes to in one column, essentially, and then the remaining fractional part goes in the other column. We're then going to take this 0.625, and we're going to write it underneath over on the left, and get 0.625, and we're going to repeatedly multiply by the base. 0.625 is multiplied by 2 is 1.25. I'm going to split that into 1 plus 0.25. Again, the 0.25 is going to be, we're going to repeat it over here on the left. Again, multiplying by the base that we want to go to. That gives us 0.5, so there's no integer part here. And we're going to write the 0.5 over in under the non-integer parts. Again, 0.5 is going to go over to the left. We're going to multiply it by 2. And we're going to get 1 plus nothing left over. And notice the moment that you actually hit, once this is 0, you can stop. Now, some of you might be thinking, what happens if this doesn't go to 0? What happens in that instance? And I have a separate video that's in the playlist after this one on what happens when you get a repeating pattern. Okay, so what do you do with this? I'd like you to notice the integer column now, and I'm just going to write it below, 1, 1, 0, 1. So that was the integer column. And what we do is we take this integer part, and we write the numbers after the point. So remember, our binary number is going to be also less than 1. So we're going to write that 0.8125 base 10 is equal to 0. Because the number on the left is less than 1, our number written in binary is also going to be less than 1. And now we just write the integer part, 1, 1, 0, 1, starting from the top and going down. And then the last thing we do is we recall that this is a binary number, and so we're going to write the base of 2. And that's our method. I'm going to do another example. I'm going to do an example where we're doing the same kind of operation, but we're going to instead be converting a decimal number to the hexadecimal number system. So as our other example, we're going to convert 0.734375 to hexadecimal. Okay, so once again we're using the method of repeated multiplication, so I take 0.734 excuse me, 375, and I multiply it by the base that we're moving into. Hexadecimal is base 16, so I'm going to take that number and multiply it by 16. If I do that on my calculator, I get 11 plus 0.75. And if you're thinking about 11 for a second, just hang on, we'll get there in a second. Let's just deal with the non-integer part, the 0.75. I'm going to take that non-integer part here and write it over on the left. Suppose to be consistent, I really should label my columns here, the integer and the non-integer part. Not really columns, but you get the idea. I take this and I multiply it by 16, and 0.75 times 16 gives 12 with nothing left over. Now we have to write this, but we have to remember that in the hexadecimal number system, the number 11 is actually has the symbol B. It's no longer a letter B, it's the number B, meaning 11 in our base 10 system. And 12 is a C. Now, if that number 12 were just an 8 or a 7 or any single-digit number, then you keep it as the single-digit number. But the moment that we go over 9 to 10, 11, 12, 13, 14, 15, you have to replace that two-digit number with the single character, the single symbol that we use in the hexadecimal system. And from this we can conclude that 0.734375 base 10 is equal to 0. Remember, the number in hexadecimal is going to be less than 1 because the number in base 10 is less than 1, so it's going to be a decimal, and we like to, it's a nice practice to write the leading 0. And then we take these numbers starting from the top and going down, so we'll get BC base 16. So there you have it. Thanks for watching, and I hope to see you in the next video.